1943, somewhere in Tunisia. A German mechanized workshop behind the lines. The Kübelwagens sat in the corner of the workshop, stripped down for the third time that month. Again. Hauptfeldwebel Klaus Hartwich wiped oil from his hands and stared at the exposed engine with the kind of frustration that comes from fighting the same losing battle repeatedly. The vehicle's swing axle design had failed. Again. The transaxle leaked. Again. And somewhere out in the desert, another German reconnaissance unit was operating short one vehicle because this piece of engineering sat in his workshop consuming parts, labor, and time they didn't have. Then the captured American Jeep arrived on a transport truck. Hartwich watched as two soldiers unloaded it. The vehicle looked like it had been through hell. Bullet holes stitched across the hood. One tire was shredded. Desert sand caked every surface. But it had been driven back to German lines under its own power after its crew abandoned it during a firefight. The officer who delivered it seemed almost excited. "Examine this thoroughly," the Oberleutnant said. "Command wants a complete technical assessment. They're seeing these things everywhere, and they want to know what we're dealing with." What they were dealing with looked, at first glance, like a joke. The thing was tiny, basic. The body panels were flat steel stampings that looked like they'd been hammered out by apprentices. No doors, no roof. A windshield that folded down flat. The seats were barely padded. Everything about it screamed cheap. Hartwich had spent his career working on German vehicles. Precision engineering, proper tolerances. Complex systems designed by people who understood that military vehicles required sophistication to handle the demands of modern warfare. This American thing looked like a child's toy by comparison. He assigned two of his best mechanics to assist. Obergefreiter Hans Flescher had worked at an automotive plant before the war. Gefreiter Otto Schreiber had a gift for understanding how things worked just by looking at them. Together, they'd give this American vehicle the thorough examination command wanted. They started the way they'd examine any vehicle. Complete disassembly. Document everything. Measure everything. Understand how it worked and, more importantly, why it worked the way it did. What they discovered over the next several days would fundamentally change how Hartwich understood American industrial warfare. Because this vehicle that looked like a basic joke turned out to be something far more dangerous. It was a philosophy made manifest, and that philosophy was currently defeating them. The Jeep represented something German engineering had never seriously considered. Not simplicity for its own sake, not cheap construction born of necessity, but a deliberately calculated approach to military vehicle design that prioritized entirely different values than everything Hartwich had been trained to respect. As he pulled the first components apart, he had no idea he was looking at one of the weapons that would win the war. Not through firepower or armor or speed, but through a more fundamental advantage. One that would prove impossible to counter. Hartwich directed Flescher to start with the engine while he examined the chassis. Standard procedure. Understand the powertrain first, then see how everything else connects to it. Flescher removed the hood, which wasn't really a hood so much as a flat piece of stamped metal hinged at the front. No compound curves. No careful engineering of airflow. Just a flat panel that provided access. He stared at what lay beneath. Hauptfeldwebel, you need to see this. Hartwich walked over. The engine sat there, exposed. A straightforward four-cylinder unit. He'd expected that. American vehicles tended toward less complex designs than German equipment. But what struck him was how the engine was mounted and how everything connected to it. "It's a Go Devil engine," Flescher said, reading the casting marks. "Willys Overland design. 45 horsepower, 45 horsepower. The Kübelwagen produced 50 from its air-cooled flat 4, so roughly comparable power from a slightly larger displacement. Nothing impressive. But then Flesher started pointing out details that didn't make immediate sense. Look at the mounting points. 4 rubber isolators. The entire engine can be removed by 2 men in less than an hour with basic tools. And look here. He traced the electrical system. 24-volt system, but the wiring is color-coded and runs in accessible locations. Everything is designed for access. Schreiber was examining the cooling system. The radiator is conventional, basic cross-flow design, but it's positioned for easy removal, and the hoses are standard sizes with spring clamps. Nothing requires special tools. Hartwich knelt down to examine the undercarriage while they worked on top. What he saw there seemed almost perverse to someone trained in German engineering philosophy. The frame was straightforward ladder construction. 2 parallel rails with cross members. Basic box section steel. No complex torsion. No intricate engineering. Just straight rails. But the suspension made him stop. 4 wheels. 4 independent semi-elliptic leaf springs. 1 per wheel. That was it. No elaborate trailing arms. No swing axles like the Kübelwagen. No complex geometry attempting to optimize wheel travel and camber control. Just leaf springs and basic shackles. Rough. Primitive even. Except when he looked closer at the mounting points and shock absorbers, he noticed something. Every component was accessible. Every bolt was a standard size. The shock absorbers were straightforward lever-action units that could be replaced without removing other components. The leaf springs were mounted with basic shackles that required no special tools to service. Hauptfeldwebel, we need to look at the transfer case, Flesher called from beneath the vehicle where he'd crawled with a light. This is unusual. Hartwich joined him under the chassis. The transfer case sat behind the transmission. Elementary 2-speed unit providing high and low range to both axles. 4-wheel drive was permanent when engaged. No complex center differential like German all-wheel drive systems attempted to incorporate. Just a straightforward gear reduction and power split to front and rear axles. It's unsophisticated, Flesher said. No attempt to optimize power distribution. No compensation for different front and rear wheel speeds during turning. Just brute force power to all 4 wheels. How is the front axle driven? Hartwich asked. They traced the drive lane. An uncomplicated open drive shaft ran from the transfer case to the front axle. The front axle itself was a solid beam with basic Arzepa constant velocity joints at the wheels, allowing steering while driving the wheels. Elementary, unrefined, effective. Schreiber had moved on to examining the brakes. Hydraulic, he called out. All 4 wheels. Standard single leading shoe drums. Conventional wheel cylinders. The entire system uses common pipe fittings and flexible hoses. Over the next 2 days, they dismantled the entire vehicle. Every component, every system. They measured clearances, documented specifications, examined materials and construction methods. The picture that emerged was consistent across every system. The transmission was a 3-speed manual, conventional synchronizers. Nothing advanced, but robust and easy to repair. The clutch was a standard single dry plate design accessible by removing the transmission, which itself could be done in under 2 hours. The electrical system was 24-volt, but used conventional components. The distributor was standard. The starter was a conventional Bendix drive design. The generator was a basic brushed unit. Every electrical component could be replaced with basic tools. The fuel system was gravity-fed from a tank to a mechanical pump to a single downdraft carburetor. No fuel injection. No complex metering. Just proven technology. Even the body construction followed the same philosophy. flat steel stampings welded to the frame. No compound curves requiring complex dies. No elaborate panel beating. The hood, fenders, body panels, all elementary shapes that could be stamped quickly with minimal tooling. Hartwich compiled notes as his mechanics reported findings. A picture was forming, but he didn't yet understand what he was looking at. To someone trained in German engineering philosophy, where precision and refinement indicated quality, this vehicle seemed almost insulting in its lack of sophistication. The steering system exemplified the approach. Straightforward recirculating ball steering box. Solid tie rods. No elaborate geometry attempting to optimize Ackermann's steering angles or reduce steering effort through complex linkages. Just a basic system that worked. I can replace any major component on this vehicle with basic hand tools, Flescher said on the third day. Engine, transmission, transfer case, axles, suspension components. Nothing requires special equipment or factory tooling. The tolerances are loose, Schreiber added. Much looser than our specifications allow. But they're consistently loose. Everything is designed to work with clearances that would fail German inspection standards, but the entire system is designed around those clearances. Hartwich was beginning to understand something, but the full implication hadn't crystallized yet. He decided to do something unconventional. He wanted to see the vehicle operate. They reassembled it entirely. The process took less time than disassembling it had. Everything fit together without fuss, no careful alignments, no precise adjustment of intricate systems. Components bolted together with standard fasteners and worked. The fuel tank still had American gasoline in it. Hartwich climbed into the driver's seat. The steering wheel was plain. The dashboard was minimal. A few gauges, some switches, nothing elaborate. He turned the key and pressed the starter. The engine caught immediately. Rough idle, but it ran. He let it warm up for a few minutes, then engaged the clutch and shifted into first gear. The transmission engaged smoothly despite loose tolerances. He drove the vehicle slowly around the workshop yard. 45 horsepower didn't sound like much, but the vehicle weighed only 1,200 kilograms. The power-to-weight ratio was actually quite good. The four-wheel drive engaged with a basic lever. No elaborate controls. Just pull the lever and power went to all four wheels. He drove it over rough ground near the workshop. The suspension soaked up impacts with straightforward efficiency. The leaf springs flexed, the shocks damped, and the vehicle kept moving. No refinement. Just basic mechanical components doing elementary tasks effectively. Then he understood. Before we continue, subscribe to the channel and leave a comment telling me where you're watching from. These are the stories that challenge everything we thought we knew about World War II. Hartwich called his mechanics together that evening. The reassembled Jeep sat in the workshop, now thoroughly documented. He'd compiled a complete technical assessment for command. But he wanted to discuss something with men who would understand the implications. "We've been examining this vehicle as if it were a German design executed poorly," he began. "That's wrong. This isn't a German design executed poorly. It's an entirely different philosophy executed brilliantly." Flescher looked skeptical. "Brilliantly?" "Hauptfeldwebel, the tolerances are terrible. The engineering is unrefined. Nothing about this would pass German quality standards." "Exactly," Hartwich said, "and that's the point. This vehicle isn't designed to meet German quality standards. It's designed to meet entirely different requirements." He walked over to the Jeep and rested his hand on the hood. "Consider what this vehicle accomplishes. Four-wheel drive, ability to carry 4 men or equivalent cargo, can traverse terrain that would stop conventional vehicles. Straightforward enough that minimally trained mechanics can maintain it. Robust enough to survive combat conditions. And here's what we haven't discussed. How many of these do the Americans have?" Schreiber consulted notes from the intelligence report that had accompanied the vehicle. Estimates suggest they're producing 15,000 per month. Maybe more? The exact figure is unclear. 15,000 per month, Hartwich repeated. We produce about 15,000 Kübelwagens per year. They're making that many of these in a single month. The implication hung in the air. Flesher broke the silence. That's not possible. Vehicle production at that scale would require... The industrial capacity is simply too large. Unless the vehicle is designed from the start for mass production, Hartwich said. Look at every design choice through that lens. Why flat stamped panels instead of compound curves? Because flat stampings require basic dies and can be produced faster. Why uncomplicated leaf spring suspension instead of refined geometry? Because leaf springs can be manufactured quickly and require no intricate assembly. Why loose tolerances instead of precision fits? Because loose tolerances mean faster production and easier assembly. He walked around the vehicle as he talked, pointing out details. Why standard fasteners throughout instead of specialized bolts? Because standard fasteners are already in mass production. Why basic electrical systems instead of advanced controls? Because straightforward systems can be installed quickly by semi-skilled workers. Every single design choice optimizes for speed of production and ease of maintenance. But the performance suffers, Flesher objected. The Kübelwagen is a superior vehicle in many respects. Better power-to-weight ratio, more refined suspension, tighter engineering. Is it superior? Hartwich challenged. The Kübelwagen requires specialized training to maintain properly. The swing axle suspension needs careful alignment. The air-cooled engine requires understanding of cooling fin maintenance. The transaxle is elaborate and difficult to repair in field conditions. Yes, when perfectly maintained by trained mechanics with proper parts supply, it's an excellent vehicle. But how often are those conditions met in combat? Schreiber was starting to understand. The Jeep is designed assuming poor maintenance and limited part supply. Worse than that, Hartwich said. It's designed assuming it will be maintained by soldiers with minimal training using whatever tools are available. Look at this engine mounting system. 4 bolts. Standard size. Any soldier with a wrench can remove the engine in an hour. How long does it take to remove a Kübelwagen engine? 6 to 8 hours with proper tools and trained mechanics, Flesher admitted. And if the engine fails in combat conditions, the vehicle is effectively lost. Exactly. But if this Jeep's engine fails, any soldier can swap it out with basic tools in an hour. They don't need to repair the failed engine. They just replace it with a spare and keep moving. The failed engine goes back to a depot where it can be rebuilt properly. The Jeep stays operational. Hartwich pulled out the technical manual that had been captured with the vehicle. He'd examined it carefully. The manual was clear, straightforward, illustrated extensively. It was written for someone with minimal mechanical knowledge. Step-by-step procedures for every maintenance task. Plain language, clear diagrams. This manual assumes the user is not a trained mechanic, he said. It walks them through every procedure as if they've never done it before, and the vehicle is designed so that following these basic procedures actually works. Nothing requires judgment or expertise. Just follow the steps. He opened to a page showing engine removal, 12 steps, clear illustrations, standard tools required. Any soldier who could read could perform the procedure. Now think about logistics, Hartwich continued. How many different parts does a Kübelwagen require? How many are specialized, manufactured only for that vehicle? Flesher didn't have an exact count, but he understood the implication. Many of the components are purpose-built. The engine, transaxle, suspension components, they're specific to the Kübelwagen or shared only across limited vehicle families. This Jeep uses common components wherever possible. Standard spark plugs, common oil filters, conventional bearings, elementary fasteners. The parts that are unique to the Jeep are straightforward enough to manufacture quickly. Everything else comes from existing supply chains. Schreiber was examining the parts manual now. The entire vehicle is divided into basic assemblies. Each assembly can be replaced as a unit. You don't repair a failed distributor, you replace the entire distributor with a new unit. Same with the carburetor, starter, generator, everything. Which means, what for field maintenance? Hartwich prompted. Faster repairs, lower skill requirements, simpler part supply. Instead of stocking thousands of individual components, you stock complete assemblies. A field mechanic doesn't need to rebuild a carburetor. He just swaps the entire unit. Hartwich nodded. Now extrapolate that philosophy across 15,000 vehicles per month. How many spare parts do you need to manufacture? How many trained mechanics do you need? How much time does each vehicle spend in maintenance versus operational service? The mathematics was brutal. If German vehicles required twice as much maintenance time and 10 times as many specialized parts, then American numerical superiority wasn't just in vehicle numbers. It was in operational availability. A force with 15,000 Jeeps might have 12,000 operational at any given time. A force with 15,000 Kübelwagens might have 8,000 operational. There's something else, Flaker said slowly. He was looking at the chassis with new understanding. This vehicle is designed to be produced by an industry that doesn't build vehicles. Hartwich waited for him to elaborate. Look at the construction. Flat stampings, basic wells, standard fasteners, elementary assemblies. A factory that makes farm equipment could build this. A factory that makes railroad cars could build this. The specialized automotive knowledge required is minimal. You're not building a complex machine. You're assembling straightforward components. Which means the Americans can convert any heavy industrial facility to Jeep production with minimal retooling, Hartwich said. A German vehicle factory takes years to build and train workers for. An American Jeep factory can be set up in months using existing industrial facilities and semi-skilled workers. The full implication was starting to crystallize. This wasn't just a different design philosophy. It was a different approach to industrial warfare. German doctrine assumed limited production of refined equipment operated by trained specialists. American doctrine assumed unlimited production of uncomplicated equipment operated by minimally trained soldiers. We're fighting their industrial capacity, Schreiber said quietly. Not just their military. Hartwich picked up his technical assessment. He documented everything. Specifications, measurements, materials, construction methods. But the real assessment wasn't in the technical details. It was in understanding what those details revealed about American strategic thinking. Command wants to know what we're dealing with, he said. What we're dealing with is an enemy that has solved the mass production problem entirely. They're not trying to build the best vehicle. They're trying to build the vehicle that can be produced fastest, maintained easiest, and deployed in the largest numbers. And they've succeeded. He thought about the Kübelwagen sitting in the corner. Beautiful engineering, refined design, and irrelevant if it couldn't be produced fast enough or kept operational in field conditions. How many of these Jeeps did intelligence estimates suggest the Americans have built? He asked. Flesher checked the report. The estimate is over 100,000 already in service. Production is increasing. 100,000. The entire German military probably didn't have 100,000 vehicles of all types combined. And the Americans had built that many of just this one vehicle type, and they were increasing production. "We need to include this analysis in the assessment," Hartwich said. "Command needs to understand this isn't just about the vehicle. It's about the industrial system that can produce it at this scale." Before sending the assessment to command, Hartwich wanted to understand one more critical question. How much punishment could the vehicle actually take? The Jeep had already been through combat. Bullet holes proved that. But he wanted to systematically test durability under controlled conditions. If the Americans were building these things by the hundreds of thousands, they must be confident in their ability to survive combat conditions despite unrefined engineering. He explained his plan to his mechanics. "We're going to abuse this vehicle deliberately, push it beyond normal operating parameters, see where it breaks and how it breaks." They started with the engine. Hartwich drained the oil, replaced it with contaminated oil mixed with desert sand, and ran the engine hard. The engine didn't die immediately. It ran rough, power dropped, but it continued operating. After 2 hours of abuse, it finally seized. They tore it down. The damage was extensive. Cylinder walls were scored. Bearings were destroyed. The crankshaft was damaged. But here was what struck Hartwich. The damage was contained to the engine itself. The contaminated oil hadn't propagated through the system. The uncomplicated design meant failure modes were predictable and isolated. They installed a replacement engine. The swap took 90 minutes with basic tools. The vehicle was operational again. Next, they tested the suspension. They drove the Jeep repeatedly over obstacles that should have broken components. Rocks, ditches, harsh terrain. The leaf springs flexed, sometimes dramatically. The shocks absorbed impacts. Eventually, after sustained abuse, one leaf spring broke. Replacing it took 40 minutes. 4 bolts per end. Lift the vehicle, remove the broken spring, install a new one, torque the bolts. Done. The vehicle was operational again. They tested the transmission by deliberately grinding gears and forcing shifts without using the clutch properly. The transmission continued functioning despite abuse that would have destroyed more refined units. Eventually, the synchronizers wore enough that shifting became difficult. But the transmission still worked. A skilled driver could still shift by double clutching and matching engine speed. The four-wheel drive system proved remarkably robust. They engaged it on hard surfaces, which should have caused binding and stress on the drivetrain. The system didn't include elaborate differentials to compensate, so the tires scrubbed and components stressed. But nothing broke. The straightforward design meant there were fewer failure points. Flesher conducted an experiment with the electrical system. He deliberately introduced poor connections, corroded terminals, and damaged wiring. The system continued functioning. The 24-volt design provided enough voltage that even degraded connections still carried sufficient current. The basic conventional components were forgiving of poor conditions. "Everything degrades gracefully," Flesher observed. "There's no catastrophic failure mode. Components wear out gradually, and the vehicle continues operating even with degraded performance." Hartwich understood the implication. A refined vehicle with tight tolerances fails suddenly when tolerances are exceeded. An unrefined vehicle with loose tolerances continues operating even when conditions deteriorate. In combat, where maintenance is poor and conditions are terrible, graceful degradation was more valuable than peak performance. They tested the fuel system by running the vehicle with contaminated fuel. The straightforward mechanical fuel pump and basic carburetor coped reasonably well. The engine ran rough, power dropped, but it kept running. A more advanced fuel injection system would have failed entirely. The cooling system proved adequate despite being conventional. They ran the engine hard in desert heat. The radiator and basic fan provided enough cooling to prevent overheating under conditions that would have challenged more elaborate systems. After a week of systematic abuse, the Jeep was still operational. Damaged, yes. Worn, certainly. But still capable of driving under its own power. And every component they'd broken had been replaced quickly with basic tools. Hartwich compiled this data into his assessment. The vehicle's durability wasn't from refined engineering. It was from straightforward, robust design that tolerated poor conditions and degraded gracefully. In military terms, it was far more valuable than theoretical peak performance. He included one more section in his assessment, a comparison of maintenance requirements. Based on their testing and examination, he estimated a Jeep required roughly half the maintenance hours of a Kübelwagen per 1,000 kilometers of operation. And the maintenance required could be performed by soldiers with minimal training rather than specialized mechanics. The mathematics cascaded. If each Jeep required half the maintenance time and could be maintained by minimally trained soldiers, then the same maintenance infrastructure could support twice as many vehicles. And if production was 10 times higher, the numerical advantage compounded dramatically. "We're not just outnumbered," Hartwich said to his mechanics. "We're out-systematized. They've built an industrial warfare system that we can't match with our approach." He thought about the German emphasis on quality over quantity, precision engineering, refined design. It worked when you had the industrial capacity to support it and trained personnel to operate it. But when facing an enemy that could overwhelm you with straightforward, robust equipment produced in unlimited quantities, refinement became a liability. The Americans had solved a different problem than German engineers had considered. Not, how do we build the best vehicle? But, how do we build enough vehicles to equip a massive military force, keep them operational in terrible conditions with minimal training, and produce them faster than they can be destroyed? The Jeep was the answer to that question. And there was no German counter to it because the counter required an entirely different industrial and military system. Stories like these reveal complexity behind ordinary objects. If you think this level of detail matters, hit subscribe and leave a comment with your thoughts. Hartwich's assessment reached command through proper channels. The response surprised him. He was ordered to prepare a detailed briefing on American production capacity based on his analysis of the Jeep. Command was beginning to understand that the vehicle itself was less important than what it revealed about American industrial capability. He spent 3 weeks compiling data, interviewing prisoners who had worked in American factories, analyzing captured documents, and building a mathematical model of American Jeep production. What emerged was terrifying. The Americans had contracted 3 primary manufacturers for Jeep production: Willys Overland, Ford, and American Bantam. But the design was standardized. Any of the 3 could produce components that would fit vehicles from the others. The concept was elementary: maximize production by spreading it across multiple facilities while maintaining complete interchangeability. Willys Overland's main plant in Toledo, Ohio, had been converted from civilian automobile production. Ford's plants in various locations were also converted facilities. The conversion process took months, not years, because the Jeep was straightforward enough that existing automotive infrastructure required minimal modification. Each plant operated multiple shifts, 24-hour production. Workers were trained in a matter of weeks because each worker performed basic, repetitive tasks. No comprehensive understanding of the complete vehicle was required, just the ability to perform specific assembly operations. The assembly line process was ruthlessly efficient. Components arrived from suppliers already manufactured to specification. Workers assembled them in sequence. Flat stamped panels were welded to chassis in basic jigs. Engines arrived as complete assemblies and were mounted in minutes. Transfer chases, axles, all installed as complete units. Quality control was statistical rather than individual. Not every vehicle was tested exhaustively. Sample testing ensured production quality remained within acceptable tolerances. Acceptable, not perfect. The loose tolerances meant acceptable ranges were wide. Defect rates were low because the design was forgiving. Hartwich calculated production rates based on the best available intelligence. Willys Overland was producing approximately 8,000 Jeeps per month. Ford was producing roughly 7,000 per month. Smaller contractors and subassembly manufacturers added additional capacity. Total production was conservatively estimated at 15,000 per month and increasing. 15,000 per month meant 180,000 per year. In 1 year, American factories would produce more Jeeps than Germany had produced total military vehicles in the entire war to that point. And Jeeps were just one vehicle type. The Americans were also producing trucks, half-tracks, tanks, artillery tractors. He included comparative analysis in his briefing. German vehicle production was constrained by several factors: limited industrial capacity, shortage of raw materials, dependence on skilled labor, advanced designs that required time-consuming manufacturing processes. Each factor limited production rates. American production suffered none of these constraints. Massive industrial capacity, access to global raw materials through control of shipping lanes, ability to use semi-skilled labor for straightforward assembly operations, designs optimized for rapid production. But the mathematics went deeper. Production rate was only one variable. Operational readiness was another. A vehicle in maintenance is not a vehicle in service. If German vehicles spent 30% of their time in maintenance and American vehicles spent 15%, then operational availability compounded the production advantage. Hartwich created a scenario comparison. Two forces, each with 1,000 vehicles. Force A has refined vehicles requiring significant maintenance. Force B has uncomplicated vehicles requiring minimal maintenance. At any given time, Force A might have 700 vehicles operational. Force B might have 850 operational. Force B's effective strength is 20% higher despite equal total numbers. Now apply production rates. Force A produces 1,000 vehicles per year. Force B produces 10,000 vehicles per year. After 1 year, Force A has 2,000 total vehicles with 1,400 operational. Force B has 11,000 total vehicles with 9,350 operational. The operational advantage is 6-to-1 despite the total vehicle advantage being 5-to-1. Extend the timeline. After 2 years, Force A has 3,000 total vehicles with 2,100 operational. Force B has 21,000 total vehicles with 17,850 operational. The operational advantage is now 8-to-1. The mathematics were brutal and undeniable. Unless Germany could somehow match American production rates, which was impossible, or inflict losses faster than America could produce replacements, which was also impossible, the numerical advantage would become overwhelming. Hartwich included strategic implications in his assessment. The Jeep enabled new tactical capabilities. Four-wheel drive vehicles could traverse terrain that stopped conventional vehicles. This meant American forces had greater mobility and flexibility. They could outflank positions that geography should have protected. They could supply forces in terrain previously inaccessible to logistics. The Jeep also enabled decentralized command. When commanders at every level had their own transport, they could move rapidly to observe conditions, make decisions, and communicate orders. German commanders often depended on motorcycles or vehicles that couldn't traverse rough terrain. American commanders could go anywhere their troops could go. Supply lines benefited dramatically. Thousands of Jeeps could distribute supplies across rough terrain to dispersed units. German supply lines depended on roads and rail. Destroy the infrastructure, and German units became isolated. American units could be supplied across country by Jeep columns. Artillery observation benefited from Jeep mobility. Forward observers could rapidly reposition to maintain line of sight. Fire direction could be conducted from mobile positions. The static artillery positions that German doctrine preferred became vulnerable to American counter-battery fire directed by mobile observers. Infantry mobility increased dramatically. A Jeep could carry a squad of soldiers faster and farther than they could march. This enabled rapid response, quick redeployment, and pursuit operations that German infantry on foot or dependent on limited transport couldn't match. Communication improved when signals officers had mobile platforms for radio equipment. The Jeep's electrical system could power portable radios. This enabled forward communications posts that could reposition as tactical situations changed. Medical evacuation benefited enormously. Jeeps could reach wounded soldiers in rough terrain and transport them rapidly to aid stations. German medical evacuation often depended on stretcher bearers carrying wounded over long distances to road-accessible collection points. American wounded received faster treatment, improving survival rates and maintaining morale. Every function of military operations benefited from having thousands of uncomplicated, reliable mobile platforms available. The Jeep wasn't a weapons system itself, but it was a force multiplier for every other system. Artillery became more effective, infantry became more mobile, supply became more flexible, communications became more robust, medical care improved, and the Americans had built over 100,000 of them already, with production still increasing. Hartwich concluded his assessment with a section that he knew would be uncomfortable for command to read, but intellectual honesty required it. The Jeep represented an American approach to warfare that Germany could not counter with existing doctrine and industrial capacity. German warfare doctrine emphasized quality of equipment, skill of soldiers, and refinement of tactics. It worked when Germany faced enemies with similar or lower industrial capacity. But facing an enemy that could overwhelm numerical disadvantages through sheer production volume, skill and refinement became less decisive. The Americans didn't need the best vehicle. They needed enough vehicles. They didn't need the most advanced tactics. They needed tactics that could be executed by minimally trained soldiers using basic equipment in overwhelming numbers. They didn't need to win through brilliance. They needed to win through attrition. And they had built an industrial system perfectly suited to that approach. After submitting his assessment, Hartwich continued gathering information about the Jeep from field reports, prisoner interrogations, and captured documents. Every piece of data confirmed his analysis and added new dimensions to understanding American industrial warfare. Intelligence reports from the Eastern Front described Soviet forces using American-supplied Jeeps through the Lend-Lease program. The vehicles were performing well in Russian winter conditions that destroyed conventional vehicles. The elementary design meant Soviet soldiers with minimal training could maintain them. American supply of vehicles was helping Soviet forces maintain mobility during offensive operations. The strategic implication was significant. America was producing enough Jeeps not just to equip its own military, but to supply allies as well. The industrial capacity was so enormous that surplus production could be diverted to other nations while still meeting American military requirements. Reports from North Africa described British forces using Jeeps extensively. British commanders praised the vehicle's reliability and ease of maintenance. British Special Forces had modified Jeeps for long-range desert patrols, mounting machine guns and adding extra fuel and water capacity. The straightforward design made field modifications easy. This revealed another advantage Hartwich hadn't fully considered. The Jeep was adaptable. The basic chassis and body could be modified for specialized roles. Ambulance variants, communications variants, weapons platforms, reconnaissance vehicles. The fundamental design was flexible enough that a single vehicle type could fill multiple roles with elementary modifications. German vehicle design tended towards specialization. Different vehicles for different roles, each optimized for its specific purpose. This required producing and maintaining multiple vehicle types. The Americans were discovering they could use one basic vehicle for many purposes, simplifying production and logistics. Prisoner interrogations provided insight into American training and maintenance practices. Captured American soldiers described brief mechanical training that focused on basic maintenance and elementary repairs. They weren't trained as mechanics. They were trained to perform specific procedures, change oil, replace filters, check fluid levels, swap straightforward components. The procedures were standardized and documented clearly. One captured American mechanic described the parts supply system. Standard assemblies were stocked at different levels. Company level had basic components like filters, belts, and spark plugs. Battalion level had major assemblies like starters, generators, and carburetors. Regiment level had complete engines, transmissions, and axles. The system was designed so that repairs could be completed at the lowest possible level, with complete assemblies swapped rather than repaired in place. This approach minimized the time vehicles spent in maintenance. A company-level mechanic could handle basic service in minutes. A battalion-level mechanic could swap major components in hours. Only complete rebuilds required sending vehicles to regimental or higher-level maintenance facilities. Most repairs were completed quickly at forward levels. Hartwich compared this to German maintenance practices. German doctrine emphasized repairing components rather than replacing them. A failed generator would be rebuilt, not replaced. This made sense when production capacity was limited and every component was valuable. But it meant longer maintenance times and higher skill requirements. The American approach only worked if production capacity was sufficient to continuously supply replacement components. The fact that Americans could afford to treat major assemblies as disposable consumables revealed the scale of their industrial capacity. Field reports from Italy described American Jeep columns supplying mountain positions along routes that conventional trucks couldn't traverse. The four-wheel drive capability and lightweight meant Jeeps could navigate rough terrain that limited German logistics to pack animals. American units in mountain positions were better supplied than German units in similar terrain. This tactical advantage cascaded into operational effects. Better supplied American units could sustain operations longer. They had ammunition, food, medical supplies, and equipment that German units in comparable positions lacked. Superior logistics enabled by vehicle mobility translated directly into combat effectiveness. Reports from Normandy after D-Day described thousands of Jeeps coming ashore in the initial waves. The vehicles enabled rapid movement inland despite destroyed infrastructure. Beach-to-front transport was conducted by Jeep columns that could move across rough terrain, through fields, and along damaged roads. German reinforcements were confined to roads and rail, which Allied air power interdicted. American forces had mobility that German forces couldn't match. One intelligence report included captured American planning documents for Operation Overlord. The logistics planning allocated Jeeps at extraordinary densities, not just for commanders and specialized roles, but for general transport. The Americans had planned to land enough vehicles to motorize their forces comprehensively. German forces still depended heavily on horses for transport. In 1944, the German military was using more horses than vehicles for logistics in many sectors. The Americans were using more vehicles than horses. The contrast was medieval versus industrial. Hartwich included this data in supplementary reports to command. Each piece of information added detail to the larger picture. The Jeep itself was straightforward, but it was embedded in a comprehensive system of industrial production, logistics, maintenance, and tactical employment that represented a fundamentally different approach to warfare. He received occasional requests from command for specific analysis. Could Germany produce a similar vehicle? His answer was technically yes, but practically no. Germany could design and build an uncomplicated vehicle similar to the Jeep. But Germany couldn't build the industrial infrastructure to produce it at American scale. And without the scale, the tactical and operational advantages wouldn't materialize. The few attempts to capture Jeeps for German use faced immediate problems. The vehicles used different fuel, different lubricants, and different spare parts than German vehicles. Operating captured Jeeps required maintaining separate supply chains. For a few vehicles, this was manageable. For the hundreds that would be needed to make tactical difference, it was impossible. Some German units used captured Jeeps despite supply challenges. Frontline reports occasionally mention German reconnaissance units or commanders using American Jeeps. But these were isolated instances, not systematic employment. and the fact that German soldiers preferred captured American vehicles to issued German vehicles was itself revealing. Hartwich heard stories about Waffen SS units specifically targeting jeeps during American attacks, not because the jeeps were dangerous in themselves, but because killing the jeep killed American mobility and communications. A commander's jeep destroyed meant slower command response. A supply jeep destroyed meant supplies didn't reach their destination. A medical jeep destroyed meant wounded weren't evacuated. The jeep had become integral to American operations. But the Americans had so many that destroying individual vehicles barely mattered. Lose one jeep, another replaced it. The production volume meant losses were acceptable. German forces were discovering that even when they achieved tactical victories and destroyed American equipment, the equipment was replaced faster than it could be destroyed. This was the fundamental problem the jeep represented. It wasn't an insurmountable weapon. It was an insurmountable system. Industrial capacity that could produce equipment faster than combat could destroy it, maintain it with enough simplicity that minimally trained soldiers could keep it operational, and employ it in sufficient numbers that tactical successes became operationally irrelevant. Hartwich had been a mechanic for 20 years. He understood vehicles. He understood engineering. He thought he understood warfare. Examining the jeep taught him that warfare had changed. Industrial capacity was now as decisive as tactical skill. Production volume mattered more than equipment quality. Logistics and maintenance determined outcomes as much as combat performance. The jeep was unrefined. It was basic. It was unsophisticated. And it was winning the war. By late 1944, Hartwich had examined several more captured jeeps. Each confirmed his initial analysis. The design remained consistent, straightforward, robust, producible in massive quantities. But he'd also seen how American forces employed them, and that revealed the final dimension of why the jeep mattered. A weapons carrier jeep could mount a 50 caliber M2 machine gun on a pedestal mount behind the passenger seat. This created a highly mobile fire platform. The combination of four-wheel drive mobility and heavy machine gun firepower meant American units could rapidly position suppressive fire wherever needed. German forces had nothing comparable. Heavy machine guns were typically emplaced in static positions or mounted on larger vehicles. The mobility transformed tactical employment. American squads could advance with heavy weapons support that could reposition instantly. German heavy weapons were either static emplacements that could be bypassed or vehicle-mounted weapons tied to roads. The Jeep-mounted 50 caliber could go and provide fire support continuously. Reconnaissance jeeps equipped with radios became mobile observation posts. They could penetrate enemy territory, observe positions, and radio intelligence back immediately. German reconnaissance typically depended on motorcycle scouts who had to return to report or use limited portable radios with restricted range. American Jeep-mounted radios had better range and didn't require the observer to leave position to report. Artillery forward observers used Jeeps to rapidly reposition and maintain visual contact with enemy positions. This enabled responsive fire support that German artillery, dependent on static observation posts, couldn't match. American artillery could shift fires rapidly based on mobile observer reports. German artillery required time-consuming repositioning of observation posts. Infantry units used jeeps for rapid redeployment. A company could load into jeeps and move several kilometers in minutes. This enabled responsive reinforcement, rapid exploitation of tactical successes, and quick withdrawal from threatened positions. German infantry moved on foot or waited for trucks that might not be available. American infantry had organic transport. Supply distribution became continuous rather than periodic. Jeeps could shuttle supplies from battalion supply points to company positions without pause. German supply typically arrived in periodic deliveries by truck to road-accessible points, then was manhandled forward. American units received continuous supply flow. Medical evacuation improved survival rates dramatically. Wounded soldiers could be loaded into jeeps and transported to aid stations within minutes. German wounded often waited hours for evacuation. The difference in survival rates was significant. American soldiers knew they'd be evacuated quickly if wounded. This maintained morale and willingness to take tactical risks. Command and control became more responsive. Commanders at every level had transport to move to critical points, observe situations personally, and make informed decisions. German commanders often made decisions based on delayed reports from subordinates. American commanders could see situations directly and respond immediately. Engineering units used jeeps to rapidly deploy to obstacles or damage requiring repair. A jeep could tow a small trailer with tools and materials to any accessible location. German engineers depended on trucks that required roads. American engineers could respond to requirements in rough terrain. Signal units established communications networks faster using Jeep mobile radio equipment. German signal units required time-consuming cable laying or static radio positions. American signal units could establish and reposition communications rapidly. Military police used Jeeps for patrol and traffic control. Logistics officers used them for route reconnaissance and supply coordination. Intelligence officers used them for liaison and information gathering. Every staff function benefited from having mobile platforms available. The cumulative effect was that American forces operated at a higher tempo than German forces. Decisions were faster. Responses were quicker. Adaptation was more rapid. The Jeep enabled this not through any particular capability, but through ubiquitous availability. When everyone had transport, everything happened faster. Hartwich saw reports from the Ardennes offensive in December 1944. German forces achieved tactical surprise and initial success. But American response was remarkably fast. Reserves moved to threatened areas within hours. Supply lines adapted to new requirements rapidly. Communications remained functional despite disruption. Much of this responsiveness came from having thousands of jeeps available for immediate redeployment. The offensive ultimately failed for many reasons, but one was that American forces could respond and adapt faster than German forces, could exploit initial successes. Mobility provided by ubiquitous jeeps meant American commanders could see situations personally, move reserves rapidly, and maintain supply and communications under chaotic conditions. By early 1945, intelligence estimates suggested the Americans had produced over 640,000 jeeps. 640,000. The number was almost incomprehensible. That was more vehicles of one type than Germany had produced of all military vehicles combined throughout the entire war. Those 640,000 jeeps were serving in every theater: Europe, Pacific, Mediterranean, China, Burma, India, North Africa. They were supplied to Britain, Soviet Union, Free French forces, and other allies. They were operating in desert, jungle, mountains, Arctic conditions. And they were performing reliably despite minimal maintenance and terrible conditions. The Jeep had become the universal military vehicle, elementary enough to produce in unlimited quantities, robust enough to survive anywhere, useful enough to serve countless roles, cheap enough to be expendable, reliable enough to be trusted. Hartwich wrote one final assessment in March 1945. By then, the war was clearly lost. But he wanted to document what he'd learned for whoever might read it after the war ended. The Jeep served as the platform that enabled every other weapon to be employed more effectively. It made logistics mobile. It made command responsive. It made supply continuous. It made medical care immediate. It made communications ubiquitous. It was American industrial warfare made manifest in 1,200 kilograms of flat steel stampings, a straightforward four-cylinder engine, leaf spring suspension, and four-wheel drive. And no amount of German tactical skill or engineering refinement could counter it. The Jeep represented American industrial warfare perfected, not advanced engineering, not innovative technology, but systematic application of mass production to create overwhelming material superiority. The Americans had looked at warfare and asked a different question than German strategists had considered. German strategy asked, how can we achieve victory with limited resources through superior tactics, training, and equipment quality? American strategy asked, how can we produce enough equipment to make tactical superiority irrelevant? The Jeep was the answer to the American question. Produce an uncomplicated vehicle in unlimited quantities. Make it reliable enough and easy enough to maintain that minimally trained soldiers can keep it operational. Employ it ubiquitously to enable mobility, supply, communications, and command at every level. Overwhelm enemy forces not through superior equipment, but through having more equipment everywhere simultaneously. It worked. 640,000 Jeeps provided mobility that Germany couldn't counter. They enabled tactical responsiveness that German forces couldn't match. They represented industrial capacity that exceeded Germany's by orders of magnitude. Hartwich had examined the first captured Jeep and thought it was unrefined. He was right. It was unrefined. But that didn't matter when you had 640,000 of them. Accounts like this deserve to be remembered. If you think so too, leave a comment and hit like for more untold stories from World War II. Hauptfeldwebel Klaus Hartwich survived the war. His detailed assessments of American vehicle production and employment were captured by American forces and later studied by military analysts. His technical evaluation of the Jeep was remarkably accurate and provided insight into how German forces understood the material disparity they faced. The Jeep served in military roles for decades after World War II. Modified versions saw service in Korea, Vietnam, and numerous other conflicts. The basic design philosophy, straightforward and robust rather than advanced and intricate, influenced military vehicle design for generations. Production of the original military Jeep ended in 1945 with over 640,000 built, but the concept survived. Uncomplicated, reliable, mobile platforms produced in large quantities and employed ubiquitously remain central to military logistics and operations. Klaus Hartwich had examined one captured vehicle in a workshop in Tunisia in 1943. What he discovered was that wars are won not just on battlefields, but in factories. The side that can produce more, maintain it better, and employ it more effectively will prevail regardless of tactical skill or equipment sophistication. The Jeep proved that straightforward solutions executed at massive scale defeat intricate solutions executed in limited numbers. It proved that industrial capacity is a weapon as decisive as any gun or tank. It proved that warfare had become industrial, and victory belonged to whoever could mobilize industry most effectively. 640,000 Jeeps didn't win World War II alone, but they represented the system that did. American industrial capacity applied systematically to overwhelm opponents materially. The Jeep was just the most visible example of that system in action. Basic, unrefined, unsophisticated, and utterly unstoppable.